So in part C, we have experiment 2, where we have a liquid-filled container completely wrapped with a material, and it is inside of the chamber with the ideal gas. We're told the area that is in contact with the gas, and we're told that the temperature of the gas is increasing, and then we're measuring the increase in temperature of the liquid. We're measuring the rate of heat transfer. And in part 1, we need to indicate what should we measure in order to determine the thermal conductivity K of the material. So what we will need to plot on the vertical axis is the rate of heat transfer, so dq over dt. And on the horizontal axis, we will need to plot the change in temperature, so the temperature of the gas minus the temperature of the liquid. As then we will be able to use the thermal conductivity equation, which states that Q over delta T is equal to K times A times delta T over L. And like that, we will be able to determine the thermal conductivity. And then we need to plot the data using the point for the quantities that are provided. So what we will plot on the x-axis, as we said, is delta T in Kelvin. And what we will plot on the y-axis is Q over delta T. This will be joules per second. So we can label it. So this will go, let's say, from 0 to 250. Like this. And then on the y-axis, we go from, let's say, 0 to 75, but let's go from 0 to 100. It makes the axis a little bit easier to scale. Or we could just go in 20 so that we fill out the entire area. It's always a good thing to consider to always try and use the entire area provided. It also makes it a little bit easier to plot the points. So we can go in 20s, and then let's plot the points. So the first one will be a delta T of 0, and we have a rate of 0. That's over here. And then the next one will be a rate of somewhere around here, 26.3. That will be here. And then the next one will be over here. And for the delta T, I'm just subtracting this from this, and I'm plotting that value. And then for the next one, it will be somewhere around here. And then the final one over here. And in part 3, we need to draw the best fit line for the data provided. So we simply draw a line that approximately passes through each point.